Oliver, on kõik või? Pane uks kinni siis. Good morning and welcome to Tallinn, welcome to Science Park Tehnopol, and also welcome online listeners. Today we have a very interesting topic. When I read few researches just during the weekend, I noticed that the most common keyword when they talked about the future of healthcare and new opportunities, it was this the artificial intelligence in healthcare. So I guess that we are living quite interesting times, and once we are able to implement AI in healthcare, things will change for sure. Today's agenda. We'll have 3 presentations. One is more theoretical, and Karl will give us a broad overview. What is AI in healthcare and how we define it. Then we will have a presentation from Estonia. Markus Karileet from HELMES, one of the biggest IT companies in Estonia. He will talk about his work, everyday work with artificial intelligence and new technologies. And then, last but not least, we will listen for Sachin Gaur from InnovatioCuris, and he will give us really concrete examples how AI is implemented in healthcare in various solutions. Few words about the project. This webinar is funded by a project called AI for Diagnostics. And our aim in this project is to implement AI in prevention and disease prediction. And really, we are trying to enhance and empower companies to use AI in their solutions. Few words about Science Park Tehnopol. So you are all here, you know where we are, but for those who are online, Tallinn Science Park Tehnopol is the biggest tech hub in the Baltic states, and also quite experienced. Last year we celebrated our 15th anniversary, and it's a foundation. Our owners are state government, and namely it's the Minister of Economic Affairs, also City of Tallinn, and our good neighbor, Tallinn University of Technology. These are our funders. And what we do here in Tehnopol, we have big business campus, a lot of office space available, and research and development services. Good partnership with universities. TalTech is our closest neighbor, but we also collaborate with other universities in Estonia and also abroad. A lot of people working in our offices and in different companies situated in the campus, and services we provide. We have a startup incubator here. We have we support companies to export their solutions, and also we have innovation programs for bigger corporates. So we try to cover the whole landscape of the companies. Healthcare is not the only focus field in Tehnopol. We also work with green technology and ICT and smart city solutions, but health tech is closer to my heart because I'm the manager of Connected Health Cluster, and this is the name of our health tech community here in Tehnopol. And in this community or ecosystem, we have we have members from or all the stakeholders in healthcare actually are presented in our ecosystem. These are big health IT companies, health startups. We have around 30 health startups in our community. Healthcare providers, because usually it works like this, that healthcare providers, they know where the problems are. and health IT and startups, they know where the solutions are. So you need to bring them together in order to have innovation in healthcare. Also universities, I mentioned you before already, and public sector organizations, Health Insurance Fund, Minister of Social Affairs, our Health and Welfare Information Technology Center, and very important stakeholder is also, of course, patients. You can't develop any solutions without end users. So this is briefly our ecosystem. Services, more closely, what we have here in Tehnopol. Usually, everything starts with a good idea, but if you don't know how to develop further your idea, from where to find funds or partners to develop your ideas, then Prototron actually is a very good point to start. Twice a year, we have a call of applications for bright ideas in healthcare also, but also other areas. And if you're strong enough, then it's an opportunity for you to get money for prototyping, and also to develop your solution further. Next step, what we have for startups is our startup incubator. We accept new applications on a weekly basis, and we have board of investors and other stakeholders evaluating companies entering our startup program. So again, an opportunity to get the support to develop your solutions. In our business unit, we provide export support. We also provide services or support to pilot your solutions in different settings, and to make your solution ready for export, because Estonia is a beautiful place where to live, but you can't make money here. You need to export your solution. And we have tools for that also here in Tehnopol. Here briefly again, circle of our services. We start with innovation, supporting prototyping, finding export contacts. We do have mentor network. Currently we have around 17 mentors in our networks. We work with the research and development partners. We do support piloting. We have at the moment, currently we are assembling or designing network of living labs, international. So at the moment we have 14 different locations, living labs in our network, where it's possible to test your health solutions. Marketing support, and of course events and networking and community membership is quite important, because our startups are quite small and you need to belong somewhere, and to discuss with other people as well. And also investment support. So we prepare companies for investors, and we also do matchmaking with different funding opportunities. But now I think that Karl is already waiting, so we can continue with our program. And first we have Karl Stroetmann from Empirica Communication and Technology Research, and he will tell us what is it all about about AI, artificial intelligence in healthcare. So Karl, you are online.
Okay, good morning. I hope you can hear me. Hello?
Yes, Karl, we can hear you, we can see you.
You can hear me, super, yes. That's fine.
So you're online, you can continue.
Get started. Yeah. Good. Okay, good morning, Piret. Thank you very much for the introduction. And good morning again to everybody who is listening and looking into this. I will present about half an hour some introduction to artificial intelligence with a specific view from the healthcare sector. I don't know, Piret and Eric, how do we organize this? I think I probably first present my slides, and then we will have, I don't know, 20 minutes or so for questions and answers and discussions. Is this correct? Okay, I don't hear anything. It's correct. Good. Thank you, Piret. Good. Then I continue. My name is Karl Stroetmann, and just to give you my background, I think this is important for understanding what I'm going to present. I'm not an engineer. I'm not an IT expert. I'm not a software guy. I am a social science guy. So my initial education was in business administration economics, but since 1992, I am with Empirica in Bonn, and through some incidences, so to say, I got into the health sector, and we developed together to a large extent with the European Commission, with many colleagues at the European Commission in those days, those early days, what is called today digital health. Initially, it was electronic health or e-health and ICT, information communication technologies in the health sector. And we got into the health sector and developed this field. And now here at Empirica in Bonn, Germany, are specializing. And we are just starting a huge 19 million euro project on semantic interoperability with respect to medicinal products globally, particularly with American colleagues. So otherwise, Empirica is a private institute, and we do a lot of strategic studies, we do a lot of economic analysis, but we do not IT analysis in the technical sense. So I cannot tell you details of artificial intelligence mathematics, but I can give you a broad introduction, which hopefully will help you to understand what we are talking about. Oops, what is now happening here? Let me see. Okay. Sorry. Okay, I have never used this software. Good. I like to start with the epigraph, and this will also give you my insight into this. I believe that technologies are here to help us, that human values and needs will have to shape technology and not the other way around. And that artificial intelligence, which is in the essence a big basket of innovations coming to fruit in the health and many other sectors, has to be human-centered innovation, has to service what we need, and thereby can support what we do and how we improve our living and our life experience. So I will first briefly look into the definition of artificial intelligence. Then I will give you a brief introduction into the history, because I think to understand the history of artificial intelligence is very enlightening. And then I will give a brief overview over technology. And I understand in the following two discussions, you get much more details on technology. And I will give also an overview of artificial intelligence applications in health. And perhaps the most interesting things for those who are in practical applications, who are not developing artificial intelligence, but who have to use it or who are expected to use it, will be the challenges we encounter. Okay. intelligence. Intelligence is a very difficult concept, and many people talk about this in qualitative terms. It's called the capacity for learning, for reasoning, for understanding, but this in itself is again, has many meanings to many different people. And we get to a higher level of intelligence when we talk about grasping truths, understanding relationships, analyzing facts, what is not a fact, what is meaning. But all of this does not allow us to really measure intelligence. And as long as we cannot really measure intelligence, it becomes very difficult to become more concrete in what we talk about. And I have here a definition by Markus Karileet. He's a young German philosopher who has been looking into the aspects we are discussing from a philosophical point of view. And for him, intelligence is our ability to solve a problem within a certain time limit, which is a very restricted definition of intelligence, but which is a definition which might be useful when we talk about artificial intelligence. Because, yes. I'm not sharing the screen. Aha, what is going wrong then? I'm sorry. Let me see what link about slideshow, black or unblack slideshow. No. Folio 6. Oh. What is going wrong here? See all slides? No. What is this here? Zuerst auf meinem Bildschirm. Weißer Bildschirm. Yeah, I'm very sorry about this. Let me let me just go Bildschirm freigeben. Can you see my screen? You can only see me, but you cannot see the screen. Yeah. Yeah, okay, please slow them. I don't know, because when we tried this a minute ago, it was working. So I go back to my slides. I'm on slide 6, but maybe we briefly go. Yeah, okay, you go to slide 6. I think this is the easiest. I apologize for this, but this is technology. Good. So I had been talking about intelligence. Intelligence has been defined as high mental capacity. I already talked about this. And then I talked about an attempt to define intelligence in a more measurable way. And you can, of course, understand a little bit about intelligence when you look at the antonyms. The antonyms you find are ignorance, stupidity, ineptness, and many other terms. So you go to the next one, please. And intelligence, when we talk about artificial intelligence, I like to contrapose it with biological intelligence. And we already talk about intelligence in plants or trees. I don't know whether you are aware that plants and trees can communicate with each other, that they can react. If like little animals are coming and eating their leaves, they react, some plants, by creating poisons against these animals. And some people already call this intelligence in living organisms. We have probably definitely intelligence in animals, particularly in monkeys, and they're particularly in apes. And then, of course, with the Homo sapiens, we talk as the animal having intelligence. But what really constitutes human intelligence, as you have this quote here, is also discussed widely, but again, it is very difficult to really understand, to grasp it in a terminology that we can handle it more than just, let's say, in philosophy. Please take the next slide. And we can contrast this with artificial intelligence. And artificial is manufactured, unnatural, non-biological. And there has been the proposal to not so much talk about artificial intelligence, because artificial is compared to biological, almost anything which is not biological, but rather focus on machine intelligence. Because what we are talking about, artificial intelligence today, is mostly embedded in machines which are created by human beings. And the antonyms are natural, biological, real versus artificial. But does this really help us? Go to the next slide. Next slide, please. And there we have more definitions of artificial versus general intelligence, because there is the theoretical aim to integrate biological and artificial intelligence into something like general intelligence, a robust theory of general intelligence, human-like or otherwise. And this remains, as you have the quote here, very elusive. We have many, many attempts. If you look around, you find almost hundreds of publications on these topics, but it is very difficult to come up with a very definite, useful wording of what we are talking about. And as you see here, about 50 to 100 years ago, the original ambition of artificial intelligence was the creation of software and or hardware systems with general intelligence comparable to and ultimately perhaps greater than that of human beings. And you see the quotes I have here are from 1980, so they're almost 40 years old, when people were already discussing these kind of concepts. Go to the next slide. And what is probably more helpful is the differentiation between weak and strong artificial intelligence. Weak intelligence is what we will be speaking more or less in the rest probably of this whole seminar. Weak artificial intelligence is systems that carry out specific, quote, intelligent behaviors in specific contexts. And this is very important to understand today's discussions on artificial intelligence. It is very specific behavior for specific tasks. So all the machines we have and where we talk about artificial intelligence applications are very task or problem specific. And there is not a trace of general intelligence that you can use one task right now and 5 minutes later a different task, and tomorrow completely different task with the same machine. So we have here a very narrow perspective on intelligence. And this is compared with artificial general intelligence. It's a very fuzzy concept. And it's aimed at bridging the gap between current artificial intelligence programs and the types of artificial general intelligence systems commonly known in fiction. I mean, when you have fiction, if you have movies, there you see artificial intelligence, which is like human beings or is even more capable than human beings. But you see already here the reference to commonly seen in fiction is that in the scientific field, in the business field, and the health field, we still have not come to grips with any of these kind of far-reaching concepts. And strong artificial intelligence is then compared to weak or cautious artificial intelligence as implying thinking machines. And this is obvious that by now we still have not, and probably some philosophers say will never have, thinking machines. Machines which can express intentionality. As I said, they set their own goals. They are mentally capable of human traces and things like this. And so strong artificial intelligence is kind of the long-term aim, but we do not even understand our own brain. So how can we then build machines who should replicate our brain? Next slide. And here you have a slide which I find much better to understand what are we talking about artificial intelligence these days. It is not coming from a precise measurable definition, but it's more coming from what are the functional capabilities of artificial intelligence applications. And these are really impressive. Artificial intelligence can already support our perception to find out how the world looks like. It can help us in the learning field, machine learning, deep learning, and we will come back to this. Deep learning means to automatically build, adapt models of reality. And this is right now where the most discussions on artificial intelligence focus on. They focus on machine learning. But there is much more to artificial intelligence, like knowledge representation. Knowledge representation to communicate models of the environment in which we are living in any field, in business, in health, in environment, and so on and so forth, is already happening. And this is a very important aspect. The next kind of level, you might say, is reasoning. To infer and generalize models based on existing knowledge. I think here we are not yet very far. Some of you might know the attempts by IBM, the IBM Watson machine. These attempts are at least 25 years old, but still, as at least the field in health shows, IBM Watson is not yet very far advanced with respect to generalize new models based on existing knowledge. They pretended that they are able to this, but if you look at the literature which has been published over the last 2 years in health shows, they are just able to replicate what good experts can do, and a lot of the reasoning in IBM Watson Health is based on the reasoning of experts in the field and not more. Artificial intelligence can help us in planning, in evaluating performance and making decisions. Here we have seen big progress in recent years, and I will come back later at the end of my talk, the challenges this implies, because we really have already situations where the machines take over decisions. And here we get into big ethical issues. And then, of course, acting to manipulate and move around in the real or virtual world. This again is opening up big theoretical and practical issues, ethical issues, moral issues. All the discussion about autonomous driving focus on this, because in the end, an autonomous car is acting on its own. And this has many implications for further activities. Next slide. Okay, a short history of artificial intelligence. I will just scan this, but this is very interesting because if you see already in 1315, a Spanish guy, Ramon Lull, has talked about reasoning by artificially implemented in machines. And the interesting background about this is, and this guy was rediscovered only 5 years ago, his publications were lost for, I don't know, 500 years. He developed something which is very similar to today's artificially implemented rules in machines to prove that God exists. So he was not applying this to our daily problems, but to religious issues, and trying to artificially prove that God exists, that the Holy Maria is indeed a virgin, and so on and so forth. But now some people even think he is a kind of godfather of informatics. Around 1600, Francis Bacon already developed ideas to fetter discovery, so to support discovery by artificial rules. And David Brewster, 200 years later, cited him, and he said, this will never happen. This is not possible. But already 400 some odd years ago, Francis Bacon was thinking about something what we call today artificial intelligence. And I myself was surprised to learn that the least squares method of a regression is already 200 years old. I didn't realize this. And still today, many statistical problem solving in artificial intelligence is based on this least square method and its many, many, many developments over the following 200 years. And the basic artificial intelligence concepts, as we talk about today, were developed by Alan Turing and by two guys, McCulloch and Pitts, around 1940, 1943, and they published some very basic papers on this. 1948, we had then Norbert Wiener. I don't know whether many of you still know him, cybernetics, or control on communication in the animal. He was also concerned with animal intelligence, you might say, and the machine. And also what we call today artificial intelligence was already embedded in all the theoretical and practical work on cybernetics. And the famous Turing test, which says, if you communicate with a machine and you are not sure, or you are almost sure it's a human being, but in reality it's a machine, then we have really created artificial intelligence. But this Turing test developed, or the idea of which was proposed by Alan Turing in 1950, is actually a very limited topic, limited context, because the Turing test is usually applied to a very specific problem situation. And in a very specific problem situation today, machines can kind of start to get into dialogue with human beings. But once you go into other areas, they fail totally. So this Turing test, depending on what you mean by intelligence, is not very useful here. And the first self-learning algorithms everybody's talking about today are also 60 and more years old. And the birth of deep learning, the big hype today, again, you see, was founded in 1965. Next slide. Okay, let me talk a little bit about the underlying technology, but I will try to do this very short because later you learn more about this. So basically, artificial intelligence is about algorithms. Algorithms are a self-contained sequence of mathematical instructions or rules that will give us a result for a specific problem. And I think this again is important. Artificial intelligence up to today is usually about highly specific problems in specific contexts. And this makes them so powerful on the one hand side, but on the other hand, extremely limited. Statistical methods are a basis of much of artificial intelligence. Deep learning, machine learning, pattern recognition, deep neural networks, these are the hype terms today in artificial intelligence, and we will come back to this. Natural language processing, which also in health has been discussed, I think, for 30 years, is artificial intelligence. Complex analytics for knowledge discovery. There are almost daily developing new fields, new algorithms, new models, how to discover knowledge. And here we might see big explosion of knowledge in coming years. And then you have the big simulation models, virtual physiological human, where we try to simulate the body functions, diseases, to help doctors to better understand, to reduce clinical trials. And again, here, work is going on for 20, 30 years. And today it's all called artificial intelligence. Next slide. So why, in spite of the long history of artificial intelligence, is all this hype right now? And this hype is because all these concepts, all these ideas, this different approaches, different methods, different statistical tools, and so on and so forth, have gained a completely new dimension due to the computing power. The computing power, as it's implemented in hardware, in chips, is incredible compared even to what we had 5 years ago. There is an absolute exponential explosion of computing power, which makes a lot of, let's say, mathematical work possible and can be handled by human beings, which 5 years, 10 years ago was totally impossible. We have big advances in theory, in algorithms, and we have big advances in storage capacity and access speed. I mean, if you look at your Google search, other searches, how we communicate here right now together, this also implies huge storage capacity in the background, huge speeds of access. And this then also combined with big data sources, shared, annotated data. Particularly in medicine, we do not just need data, we need annotated medical data, we need annotated images. So the big machines who are to analyze this understand what they are looking at, so to say. All of this is the basis of today's explosion in artificial intelligence. And of course, it, particularly in medicine, involves interoperability, where we are still lacking a lot in medicine, data integration. More and more, we talk about cloud services, that we don't have the computing power, the storage, and so on at home or in our hardware in the, let's say, in the basement of your building, but that it's somewhere around the world, stored wherever it is. And I remember still, that was about 10 years ago, I was at a conference in Phoenix, Arizona, and everybody was talking about the coming cloud services. Cloud services was a big hype in those days, but it didn't work yet. And today it's daily activity for all of us. And the merging of all of these techniques has allowed for today's wide implementation of artificial intelligence. I think this is also important to understand. All these technological developments in many different fields combined have allowed the progress in artificial intelligence, which we are observing right now. Now, the next slide, slide 17. I think I will not go into detail into here because I assume that the later calls presentations will explore this in more detail. I mentioned that deep learning, deep neural networks are the big basis of a lot of what is called artificial intelligence today. And what is important here is, on the one hand side, we have the input layer. These are the data, the images, whatever you use as input. And then you get what is called here hidden layer 1, hidden layer 2, and we are up now into mathematical models, I understand, with hidden layers of 1,000 and more. And here we have a big problem that experts told me, mathematical experts, we do no longer really understand what is happening within these hidden layers. And we just get output. And we can look at the output. But we don't really know what is hidden into these hidden layers and what activities are going on there. And this, of course, makes it then in the end right now quite often totally impossible to judge the output layer, to judge what is this artificial intelligence system telling us. And if we do not understand what's coming out there or how it's coming about, then particularly in health, we will see later, we are into trouble. Because we cannot just use something which the doctor does not understand how it's working internally to a patient and then hoping it's just good to the patient. Go to the next slide. These are different types of neural networks. I just wanted to show you that the whole system is extremely complex. Don't try to understand the details. I don't understand them myself. I just found this very nice presentation, and it already gives us a glimpse at how complex all of this is. This, to me, is an extremely important statement. It's from the Vienna workshop on digital humanism. There are some global experts assembled in Vienna this April, I think it was, and they try to put some perspective to all of this. And these are some quotes from their agenda, their publication, where they say, we experience a metamorphosis from the standalone computer to the global operating system. They call this the Digital World 5.0, which will digitalize everything and automate work and thinking. And this is kind of a vision of what the future might be, which is on the one hand side very optimistic and great, on the other hand frightening if we do not understand what is inside all of this. How does this Digital World 5.0 deal with ourselves, with human beings, and how do we get dependent on this? And as I say, this is already coming about permitting work, leisure, politics, professional, private life, everything. And how will we stay on top of this? I think this is going to be one of the key issues, and particularly also in health, where in the end we talk about life and death, and the doctor has to stay on top of this. Take the next slide. Briefly, quantum. Everybody talks also about quantum computing. I believe quantum computing is at least for practical applications 10, 20 years ahead of us. But once we would get into quantum computing, then the future of artificial intelligence would again change dramatically, because quantum computing opens up totally new possibilities. But the recent hype on, I think it was a quantum computer by Google, is nice, is interesting, but for practical problems, totally irrelevant. But this might change over the next 5 to 10 years. Nobody knows right now. Okay, next slide. Now let's briefly go into application in health. I would want just to give you a few examples. A typical and most widely cited example is radiology. And this makes a lot of sense when you think that 2 billion chest X-rays images are produced worldwide every year. Every year, 2 billion. And radiologists have to look at this. And this takes an enormous amount of time. It's very boring in the end, I guess, if you just look at hundreds of images every day. And if a machine can do this and if artificial intelligence can help us here, it would be fantastic. And this is a field where already the first producers of X-ray machines, of computer tomographs and so on are implementing artificial intelligence systems into their machines. As you see here, they can interpret the scans 150 times faster. So it will save an enormous amount of time for radiologists. The accuracy right now is so-so. If it are less experienced medical doctors, it is better. So it helps them a lot. If it are really good radiologists, it rarely outperforms them. And as I mentioned earlier, IBM Watson in health, they have a cancer decision support system where there are a lot of studies now being published, at least 10, 15, some very interesting from Korea. They show that Watson sometimes replicates what very good radiologists can detect on cancer, yes or no. But there are also quite a few publications which show that IBM Watson is still less accurate and less reliable. But maybe it will learn. But in the end, the decision supports the recommendations the system produces are the suggestions by a few cancer experts at the hospital in New York and not coming out of the machine. This is also to put this a little bit into perspective. Let's take the next slide, slide 23. In pathology, it will hopefully develop to become very helpful because pathology is a much more complex field than radiology. In pathology, you have so many different types of slides, of pictures, of images to interpret, to look at. And if artificial intelligence can help us to improve the assessment of pathological images, this would be really, really helpful. But the big thing we have to understand here is the machines themselves cannot do this. We have to train them. So we need hundreds, thousands, and millions of pictures which are absolutely precise from which these machines can learn. So the machines cannot learn on their own. They learn from the pictures, from the data, from the knowledge which is inputted by human beings. This is also very important to understand that the artificial intelligence, once we have this very precise, very good input data, can analyze the rest much faster than human beings. But if we have bad data input, then of course we get bad data output. Similar situation we have in cardiology. And go to the next slide. Here you have a list: dermatology, gastroenterology, genetics, predicting suicide. There are many fields where artificial intelligence application support medical professionals. At least people pretend this can be done, and there are some initial studies showing how it might be done. And the last bullet is robotics. Robotics is also coming to the forefront. That's a combination of artificial intelligence systems implemented in robotical machines, robotical persons, robotical whatever, like in care services, might also help us to cope with the aging of our societies. But these are all developing fields. Nothing is really working in the daily routine yet. Next slide. Then we have other application fields: health systems, health service provision, improved workflow, and potential for reducing medical errors. The typical decision support systems. When I started in this field 20 years ago, everybody was talking about clinical decision support systems, and we didn't talk about artificial intelligence. Today, we are still using similar systems, more improved, and today it's artificial intelligence. There are first applications to help patients, and there are also first applications to management the workforce. And here we come into systems which autonomously even decide on workforce. Select, direct, control, promote, and even fire. I think it was Uber in California, the taxi service, that they have a system where they not only promote but also fire people, not by human beings anymore, but based on decisions artificial intelligence systems prepare. And here I think we transgress an ethical border, because what is happening, the machine, what kind of input data, because something goes wrong, the machine cannot decide. I think here we still need human beings. Okay, next slide. Here I want to give you a brief exemplar. It's a backup patient decision support system. And this is to help doctors and patients in dealing with back pain. I'm not presenting this for you to get into any details. I'm presenting this to show how a complex artificial intelligence system might be constituted in the health sector. And the backup system has a research platform where you get new data, new publications, empirical data from statistics. They have a clinical professionals platform, which helps with artificial intelligence algorithms clinicians to make better diagnosis and better treatment decisions. And it involves a patient self-management platform to support patients in dealing with back pain. And they use machine learning, neural network techniques, statistical models, and other algorithms. And the more complex system is on the next slide. Here you have a conceptual diagram of this system. And again, don't go into the details of this presentation, of this picture, but just see how complex, let's say, simple artificial intelligence system for dealing with back pain might look. And this is what I believe is often overlooked when you talk about artificial intelligence in health, how complex this system can become. You see on the right-hand side, you have the research platform. On the left-hand side, you have the professional platform with all the different aspects. And the green box is the self-management platform for patients. And to keep such a system going, you might need a whole, not even small startup. You might need 20, 30 people to keep this going. And this, I guess, is also one of the big issues we have to deal with when we talk about the future of artificial intelligence, like in health. Go to the next slide, challenges. Yeah, next slide, slide 29, the artificial intelligence chasms in health. These are very important aspects to understand about the applicability or not of artificial intelligence in the health system and probably in many other fields. What we see right now are mostly publications which validate the performance of an algorithms. But the validation on past data of an algorithm is not equivalent to demonstrating clinical efficacy. So all these studies do not tell us how efficacious these systems would be in a clinical trial. You see, and even if we have proof of concept in a clinical trial, a prospective clinical trial, this does not necessarily tell us what the proof of the concept will be in improving routine clinical outcomes. In clinical studies, we talk about efficacy and not about efficiency or impact, because this is a controlled environment. But the routine daily clinical health service is not a controlled environment. It's a very fuzzy, very complex, and a very difficult context where you have interruptions, where you do not have the strong controls you have in clinical trials. And many drugs, for instance, demonstrate good efficacy in clinical trials, but in clinical routine implementation, there is almost no effect. And we are far away from demonstrating this for artificial intelligence in health. And another chasm people say is, okay, if we have now all these new insights and we have these enormous mathematical models which can predict many, many things we hope for, we foresee that we see a prediction of the risk of an adverse outcome where we have no therapy. This seems to be a real problem in health. And what do? Does it make sense to tell a patient, yes, you will have this disease over the next 5 years or so, but we can't help you, we can't treat this? Or should we ignore this and not tell patients? So this is just to inform you that artificial intelligence might have some new aspects which we have never dealt with in healthcare. Next slide. This kind of puts this together in a summary, what I have said on the challenges. To validate a digital neural network in silico, as most of the studies do right now, is far away from clinical validation in a clinical trial or from real-world medicine. And only if we have covered successfully this step, then we can think about wider implementation in healthcare. And I would expect this to be away still 5 to 10 years. We will see a lot of research. We will see a lot of these posterior studies, of these studies looking at the past. We will see many fewer clinical validations in the real world medicine, and then go from there to diffusion of innovation in healthcare. This takes, as studies show, up to another 10, 15 years. Okay, go to the next slide. Yeah, the ethical dilemma, which is something close to my heart, because I think it is very important in health that the artificial intelligence applications must be driven by human values and needs. And here we have the problem that people think about integrating ethics into the machines, but values are culturally determined by tradition, by religious beliefs. They are different by country. How can we implement such kind of rules into artificial systems? And who controls this and who decides on this? And here I think we still need much more work and much more thinking before we really come to clear decisions on this. Next slide, missing business models. I mentioned this earlier. We need a lot of input data, and we need good, high quality, annotated data in healthcare. We need to adapt these systems regularly to new regulations. We have to adapt these systems to new knowledge, new medical drugs, to new types of medical intervention. So what we really need is a continuous learning with respect to many aspects of these artificial intelligence systems. Who is going to do this? Who can make this into his business model? Who will pay for this? Unless we have solved these problems, we can do a lot of research, but it will not end up in the medical practice. Next slide. Bias of input data, widely discussed. The input repeats what people believe. I mean, the most famous example is probably in the United States, in the legal system. What people put into the artificial intelligence legal systems was their past history. And of course, these systems then decided that 80% of those who have to go to jail are black people, because they just repeated what was before. There was no new knowledge, it was just condensed and repeated. And we must avoid this. You know, and interesting is the picture recognition is class related, they found out. You know, and how do we get this bias out of this? How do we get also bias which might be in studies involved? And how do we get to the, let's say, real knowledge? Nobody has a real answer to this, but we have to be aware of these issues. Next slide. Further challenges. Yeah, what is the quality, reliability, and safety of these artificial intelligence systems? You see, these are not just a simple machine. These are interplay of various input devices, of complex algorithms, of various output devices. You see, and a big example of what can happen if we don't test them really is the Boeing 737 MAX accident. I mean, 2 airplanes came down because artificial intelligence in these machines failed. And this demonstrates us how careful we have to be about this. There are fantastic opportunities, but we have to be careful about this. And like here, where I'm living here in Germany, we are thinking about regulation and certification of artificial intelligence systems and applications. But how can you do this? Nobody knows. How can you understand what is happening in these deep learning systems? And if you do not understand what is happening, how can you certify this? Data protection is a big issue. The cybersecurity of the connected systems, of course, cybersecurity is becoming a top issue globally, legal issues. And the last point, to me, is extremely interesting and perplexing. The individual artificial intelligence system, we might be able to understand. But the tendency is to combine different artificial intelligence systems. And then our understanding really fails. How do they interact amongst themselves? What kind of decision is coming out at the end or recommendations? Nobody right now will be able to understand this. So this will be a key aspect in the future to look at. Last slide, slide 35. I personally believe there's a fantastic potential in artificial intelligence for safer, better healthcare. It will allow us to better explain, hopefully, what is happening in our bodies, what is happening when we get a disease, and how we can cure it. And it will be an important building block in what is called the learning health system, where we have continuous feedback from input through the treatment and then through the health outcome data, improving our knowledge. So artificial intelligence in healthcare hopefully will help us here tremendously. But we have to be aware of the caveats I mentioned earlier. And it will be a huge collaborative effort. And if Europe wants to sustain this and to remain or become a world leader, we have to create a European artificial intelligence for health or for whatever program and platform. Because otherwise, neither Estonia nor Germany nor any other single European country will be able to compete on its own with Asia, with China, or with the United States. So my kind of vision is, yes, fantastic opportunities, but yes, still enormous need for further improvement, for further understanding, and for future work. So I stop here. There are two more slides, an acknowledgement, which you might show, and at the end you have my address if you want to contact me. And I stop here and thank you all for listening and hope I could give you some good insights. Many thanks. Back to Tallinn.
Yeah, thank you. Sorry. Thank you, Karl, for a very interesting presentation, but at least for me, there were more questions than answers. So
yes, that's the case. I fully agree with you.
Yeah.
But I can't help it.
Yeah, for those who are online, it's also possible to ask questions. Just drop a line, either in YouTube or Facebook, and we will pick your questions from there. But in the audience, right here, do you have any questions? Well, I have just one. You listed so many obstacles, and just can you bring out one really crucial thing we should overcome before we can have those AI solutions not only in radiology but also in mental health, for instance? Can you bring out like one really important factor we should change? Is it the technology? Is it legal background? Something in our head, our thinking? What is your opinion, Karl?
Oh boy, that's a difficult question.
Yeah, and if you answer this, then we have a very good way to go on or to continue with this. So it's a million-dollar question, yeah.
You see, I think a basic issue which I come across all the time is the input data. You see, and the input data are useless unless we have a good model behind this. So artificial intelligence is kind of a model, a mathematical model, and which might be extremely complex to go from some input data, and input data means knowledge, understanding, but also facts, how to recombine this so to get an output which tells you something. And like in mental health, I could imagine there are so many scales you use in mental health. how can the application, let's say you have a patient which has to fill out 2, 3, 5 of these scales to judge what kind of mental illness he or she has, what degree it is, how they are related, that artificial intelligence will help the doctors, based on learning from these different data, to better diagnose. This would be the first step. And once I have a better diagnosis, then of course I can go the next step and also try to use artificial intelligence based on this diagnosis, based on the different types of therapies, what might be the optimal therapy for this individual patient, you know, and based hopefully, let's say, on knowledge of the last second. What have the recent publications, what did they tell me about this? But just suppose you have a patient who is willing to cooperate here or not, I don't know, I'm not an expert in mental health. I have to understand a little bit about the quality of the scales. I have to see that the input data from the patient filling in these scales are appropriate. How do I, for instance, understand, is there cheating going on from the side of the patient? Can artificial intelligence help me? And who, in training these artificial intelligence systems, who can supervise this machine, so to say, that the output is really the correct output? I mean, we have interesting examples and experiments that artificial intelligence machines can work very well with a given situation. But once there is even a little bit change in the input data, there are examples, they come out with totally crazy results, because we do not quite understand what is inside. And how do we then discover on the other side, on the output side, that this is crazy? In spite of artificial intelligence, it is totally unintelligent. You see, and this is where, at least in medicine, we still need the critical doctor. The doctor with a good background, with a good understanding, who can use this artificial intelligence system to help him or her, but who is not kind of the prisoner of these systems. They have to be tools, they have to help us, and they can improve things, hopefully very good, but they need high quality input and a good understanding on the side of the applying doctor.
Okay, thank you, Karl. Any questions online? We have a few questions online.
So one question online from Helena is that since machines are powered by AI, what does machine behavior exactly mean?
This is, I don't know whether we really can talk about machine behavior. You see, I mean, I'm not just trying to use the paradigm of the autonomous car. If a car drives right, drives left, is braking, if this is behavior, yes, then the machine would behave in this sense. You see, you could also talk about a cybernetic cycle, just a simple cybernetic cycle controlling your temperature in your home, turning on and off the valve to improve, to put more heat into your room, less heat, and so on. You could talk this behavior, you know, but I don't think this behavior in the sense of a human being is meant. If I love somebody, if I enjoy something, if I hate something, I think this might also be behavior. You see, I'm not a behavioral expert, so I can't tell you exactly how do I define behavior and how do I measure behavior. And this, of course, is also a problem in all of these discussions. We come from different language backgrounds, so we might use the same word in a different meaning. And I would say machine behavior means really how the machine acts or how the machine functions internally. But it's not similar to human behavior. But this is just a guess. I can't. I probably would have to ask an expert, and he would give you 5 opinions at the same time. Maybe. Sorry about this.
Okay, thank you, Karl. We have next speaker ready. And I hope at least some answers, right? So integrating AI and potential use cases in everyday work. So HELMES, yeah, and I didn't see you, sorry. So yeah, I hope we will have at least some answers now.
Yeah. Thank you. Yes. Let me just do some technical bits here and see if it works. Hello, everybody, and big thanks to Karl. I think he already said most of the things that I am about to say theoretically, but I'm more practical guy, so I'm hoping to show you some real practical use cases where you could actually use machine learning today. And the main idea is that you don't have to have hundreds of thousands of euros ready. You can pilot your idea rather quickly, whatever it is, unless it's not very common specifically to your business case, but it's a rather general idea. I'm a bit younger in this field, so since 2006 I have been working in IT. When I first started, the main idea was to build individual systems. Everybody were building their own systems. These weren't really tightly integrated with one another. As the years go by, the main benefit is starting to emerge from integrating different solutions. So, for example, let's say that I have an electric car and I live near the city in the suburbs. And through machine learning, the algorithm knows that every Tuesday I have a training in the city center. So taking the distance that I go there all the time, calculates how much battery I have in my car, and realizes that I don't have enough charge. If I don't put the car to charger, then I won't make it. So things like that improve our everyday life, but these are small, different components brought together by integrating different solutions. And this gives us more and more value. And AI, as mentioned before, is pretty much a tool, a hammer for other business ideas. So we cannot take it as a one-stop shop or single solution or silver bullet. It's just something that helps us to make some decisions or to guide us in our decision making. Some AI integration possibilities that are readily available more or less as a black box, basically. This means that we can take a solution such as OpenCV. It's a computer vision library that can do some OCR or computer vision implementations without us even needing the vast amount of data to train some algorithms. So it's a good place to start with some ideas. Would this work with my project? There's also Google. The cloud AI has vast amounts of different implementations of machine learning networks. So you can go there and find out whether any of these, such as face recognition, object detection, speech, can benefit to your business. And you can try them out in many cases right there in this page. So if it gives you desirable results, you know that yes, there's a possibility I could use this in my project. Maybe I will have to train my own model, but the main idea would be that, do I have enough data? Is my data valid enough to use a machine learning model? Teachable machine, this is something I will show you later on. So on stage, we will train an algorithm and use it. So don't go anywhere. It's not very accurate because it doesn't have that much input data, but you will get the understanding of where we have come with these actual implementations of different general machine learning algorithms. Some more possible integrating partners or library providers, Microsoft, of course, many cloud-based AI solutions. Yes, they are built by requests, but the cost of one request is like 1,000 of a cent or something like that. So if you want to try it out, it's free, right there in the web page. But they offer, and they continuously improve. What is great here is that if you are building your own network, your own model, then you will need the actual hardware, the servers with the GPUs. And if your project doesn't work, or the machine learning algorithms don't provide you the data that you need, then what will you do with the hardware? So, great place to start. And there's a fun place called Algorithmia. It's a free marketplace, or open marketplace for everybody to upload their own model, or use someone else's model by their own credit system. There's a bunch of, let's say, unusable stuff, or I don't know why you would need it, but then again, there's many meaningful algorithms there. So you can go and check whether someone has already trained the system. For example, the name, card, address, or contact info detector. The model understands where usually the name is, where the contact info usually resides, and extracts the data and gives it back to you in a structurized format. Just a small sample. Sentiment analysis, you can understand what's the content. Is it positive or negative? Colorizer, it's a fun tool. I will just show it because maybe it will open up some ideas for you. And the interesting area, heat map, it's another thing that you might combine with next algorithms, because it alone gives you not that much of a value, but if you combine it, for example, with the image cropping tool, then you will see the benefit. I will show it just in a second. But first, let's try to beat the machine with the sentiment analysis. So I have some quotes here. Some of them are from Twitter, so they might be not so positive. But others are from, let's say, Wikipedia. So what I would like you to do is to understand which of these is the most positive sentence, and working our way down to the most negative sentence. So which of you think that, or what number could the most positive sentence be? 1, 2, 3, 4, 5? 1. Okay, I heard more 4s. Let's take 4 is the first one, right? So the second one, this could be then the 1, right? Working our way down. Now we should be in the neutral zone someplace. We have 2, 3, or 5. 2. I heard 2. Let's take 2, right? Now, a bit negative. 5, and the most negative being the third one, right? All right, let's see what the machine thought. So this is the most positive because of all these exclamation marks, best, OMG, words that indicate it's being in a good context. But if we would add quote marks around the best sentence, the machine wouldn't catch that. So actually, it could mean the opposite. But otherwise, your prediction was correct, so to say, or let's say the machine was correct. Although this here, the fifth one, isn't actually that negative. It's quite kind of a neutral sentence, but due to having the words bias, inaccurate, this brings the, let's say, the sentence a bit downwards. So colorizer, this was I think it was the best black and white picture in 2018. It's an algorithm that finds out or thinks what these colors might have been. So this slide shows you the output of the machine and the actual picture. So it's pretty much the same, but you see that the headband here is not colored, and most likely the input data that they had, people had pictures on their t-shirts. So it's colored here a bit blue as a blob. Moving on to the interesting area heat map. So I had a site some years ago that was rating different beers. And the problem was to understand if you take a picture of a beer bottle, is it already in the system? It can be from any angle, but what I needed was the label, to crop the label out and match it with actual other labels. So from the output of the algorithm, it says that the most interesting part is here, which is correct. So I can use a cropper to crop this part out and get the right results. So maybe you have seen that if you want to put your profile picture on Facebook or whatever, so it takes the body part and then you have to adjust to your face because it doesn't understand what part you might want to expose if you have a rectangular picture, but square is allowed size. Now, these are all fun and games. I would like to show you a proof of concept that we did. So we had to read in car registration data. So this is the regular green card that you get with your car, although it's for trucks. The problem was that the regular OCR wasn't very good understanding these letters and numbers if this scan was in color, because it has all this noise in the paper. And as well, some of the letters are printed on the lines, so it confused the OCR pretty much. And we had different formats, so this is like the European one, or I think it's even not European, but most of the European countries use this, but for example, Poland has a different sort of format for it. So we tried to understand whether machine learning would be helping us here. It's a bit hard to see, but some of these fields, or most of the fields, have light gray boxes, and this is the small print is what it read out. It's not that important that you see, but it read in most of the details, except some of the letters like here, here, here. These they didn't understand, but for us they are clearly visible. This isn't a big problem, but the biggest problem is something like here. So the algorithm thought that this is one big sentence and concatenated it all. And the other one is here. So the field S1 has a value of 2, but the algorithm thought that this is S12 value. With these, we can use some additional filtering methods. We know that in this area, there should be a one-digit integer, and this field is S1, so we can extract the S1 or just find out is the integer there. This gave us enough confidence to move on with this sort of OCR, but not even using the Microsoft one. This is Microsoft OCR. But we're trying to build our own network on TensorFlow, teaching with these letters that we find on these registration sheets. And this took less than a week to understand, yes, this is a viable solution, we can move on with this. Or it might have gone the other way, saying that, okay, it's unreadable for machines as well, so we must think of another way. Now, I would like to show you how to teach a machine. So if you would be so nice to cue the screencast. Since I cannot do it on this machine, I just recorded a very fast, quick video. So it's Teachable Machine by Google. You can do different projects here. We are doing an image project called the Client Detector. It's a machine that understands who is our client and who is not. We don't have much input data, so we have some faces here. We know that these are our clients. We say that the class 1 is client class, for example, and we just add some pictures to the other class and saying that these pictures are from another clients. So it's not maybe a really good use case, so to say, but it illustrates some nice facts here. So we train the model. It takes, on a fast machine, good internet, approximately 5 to 10 seconds. But regarding on input, if you have more input, it will take a bit more time. And then you will be able to validate with some other data that was this model successful. And the good idea here is to, if you have 100% of data, you use 70% as a training model and 30 as a test model, so you understand that the model works. But let's try to see, we have some test cases here, whether these are our clients or not. So what happens here, I don't know if you noticed it, but actually I labeled the first set as clients, but these clients all had something in common. So they were all wearing glasses. And for the machine, this was the common denominator for all of the pictures. So some of these are like false positives. So for example, the Trump picture was a customer or a client, but he didn't have any glasses. But mostly, if we look at the pictures with glasses, the machine says it's a client. So it was my problem that I labeled this classifier as a client, but for machine, it was people with glasses or classes. So you have to be really, really focused on your input data. This is the bias that Karl was talking about, so you might put some bias into the system. And this is where, for example, lots of the law enforcement has failed because of this. Their input data was not generalized or really universal, but they were biased on one side. And this, I hope it plays, is a nice example of the machines. It's a approximately 3 years old girl. And the trainer is trying to show her that she must break this sheet of wood. Is it connected to the internet?
It's connected to the internet, but it's not playing. I can just in a few minutes maybe play.
Okay, so I just jump to the conclusion and then we can look at this cute video. So the main idea is that if you have some ideas, if your ideas fall into the category of prediction or classification, then machine learning can help you a lot. And if you look into these big providers, AWS, I didn't mention it, Amazon has also a big set of machines ready for you to try out, even in their own web page. Just upload a photo, upload some data, get the results. So you can understand really, really, really quickly whether my picture is, I don't know, good enough for this, whether my audio file is good enough for the machine to understand what's going on there. And if you see that, yes, there is something, we can move forward, we can add some more money into this proof of concept, then you can go on and try to train your own model or use even more hardware for this solution.
Saluda, párate.
But the main idea there is that we are showing the machine what to do without actually doing it ourselves. And in this sense, the machine learns not the actual action, but what we show them to do. And this is a fun example of the same thing that happens with humans as well.
Se cayó. Dale.
And this can be the case that if we don't know what we want to achieve with this algorithm, then the algorithm doesn't have the answer to us as well. But anyway, this goes on for a bit. My name is Markus, and thank you for being here. I hope you had some great insights, and now we can move on to our next talker who will give some health-based insights regarding AI. Thanks.
But questions? Online? No questions? No? Yeah? But please use mic.
If you give input data, for example, clients' pictures, how or even if it is possible to make learning not take account of the classes factor?
Thank you for a good question. Well, basically, it's at some point it's trial and error, but in other cases, if you would look at the input set of data and you see that there's a common denominator that actually should not be included in this algorithm. For example, you have all men pictures, but actually you don't want to train the system to recognize that, okay, if it's a man, then it's okay. If it's a woman, then it's not okay. So you have to provide, maybe you have to exclude some of your input data just to make it more diverse. So if you have maybe hundreds of pictures with glasses, tens pictures without glasses, then you even out the amount of different, let's say, factors that the system might think that it's relevant to your model. So a bit curating on the data helps a lot. So for example, for law enforcement in the United States, if it happens that at that moment they have more black people in the prison cell and less white people, then it doesn't mean that all the black people are somewhat evil. It just happens out that in this district or in this station, it happens to have this set of data, but it's only a subset of the actual data. So you must curate it a bit to make it more equal in that sense. Because if we take a person who is biased, then it's only one person. And the one person works from 8 to 5 and then goes home and doesn't do any more harm. But the machine learning model is scalable and it works 24 hours all the time, everywhere. So if we train a model to be biased, the impact is enormous. But for one person, it just evens out within the good guys, for example. So did it answer your question? Yeah. Yeah.
Thanks. I have a question about getting the right algorithm for me. Where should I start? Like, if I don't need the algorithm to detect something from the pictures, but I want a specific algorithm for me to do something, where should I start looking for it?
Okay, so if it's not computer vision where machine learning is great at the moment, if it's prediction, for example, then one place again would be either cloud AI to see whether your data is, let's say, it's computable in a way for the machine to give you some answers. But then moving on, then you would have to go into coding, find out whether TensorFlow is the right framework for your problem using some scikit-learn libraries in Python to predict the data. But then again, if you are doing this yourself, there's two options if it doesn't work. Either you get it wrong or the data is wrong. But you don't know which one of it is. So if you can validate your data on readily trained algorithms, and it can be that the algorithm is good at detecting cats, but it can be really well used to detect dogs as well. But you have to validate it with your data to understand it is probable, I will invest some time in it, or it's not probable, let's move on. So there is no good answer to you. My first suggestion would be to validate whether trained algorithms by big giants such as Microsoft or Google have already provided you, and these give you some insights that, okay, there is something in my data, it's not biased, it's giving me the feedback that I'm expecting it to give, and then you can move on to find out what's the right framework for you, and most likely widespread TensorFlow is something that can handle your data as well, because it actually, I think it doesn't matter that much, but then again, it's specific to a problem.
Any questions from the audience? So I have a question online. So one question from YouTube from Raul. Since a good quality amount of data is the basis of any machine prediction, so in machine prediction, is the owner of the best data set the winner of the game or whatever?
I suppose so, yes, because it's pretty much as goes the same, for example, in the stock market. So if you have really good insights, you have really quality data on what's going to happen, you're the winner, because you will know what's happening most probably in the next step. Yes?
You might have the best data in the world, but if your algorithm is wrong, the data quality doesn't matter. Like they're so interact together, I think. Thank you.
Yeah, it's true. You can't have one without another, but you cannot have the greatest model in the world with the bad data. So you have to have the good data to train the model to be the best in the world. But then again, if you have good data and you don't know how to train your model, then you're only halfway there, and somebody might beat you to it. But you have all the, let's say, the prerequisites to be the winner. All right, thanks.
Thank you. And we have next speaker ready. Yes. So now real life examples, and Sachin will give us a presentation, and he will give a short introduction also who he is, and we will have him online just in a second. Sachin, are you online? Can we hear you? Hello? Anybody? Silence. Just a second. There is coffee available, some snacks, sandwiches. We will find him somewhere. On olemas või?
Hello, Eric, can you hear me?
Sachin, are you online? Can we hear you? Say something.
Yeah, I can hear you very well, Piret.
Yes, now we can hear you also. So welcome. Okay. Can you share your screen, please?
Yeah, thank you. Yes, I can do that.
No, we have. Oh, we had you for a second.
Is it visible?
Not anymore, but it was just for a second. Do it again.
Okay. Yeah, let me try. You can see it now?
Yes, we can see it. So.
Okay. And if I go in the full screen mode, you can still see it?
Ah, you. Yeah, you have this full screen, but you have to choose this extended screen option. Then we can see when you put this presentation mode on.
Aha, okay. So let me not go into full screen, so
Okay.
I don't waste your time.
Okay.
And we
Okay.
can do without full screen. Yeah.
Okay, just put it then.
Yeah. Okay. So can I start?
Wait for a second. We have to invite people back because they went for a coffee. So.
Ah, okay. Sorry.
Yeah.
Sorry.
But yeah.
So, Piret, are you going to be with me for if I have to ask?
Yeah, but yeah, and we also have an opportunity to ask online. So we will read also those questions sent to us online.
My first question to the audience would be, can you see this painting, nice painting on my presentation?
Yes, we can see it. But wait for a second, Kaur. Sachin, we will just, people are coming back, so yeah. So are we ready? Yes, we can start now. So the stage is yours. And
okay.
Please, you can start.
Yeah. So hello, good morning, everyone. This is Sachin Gaur speaking from New Delhi. So really sorry if there are any technical issues, but I did study in Tartu long back. So that's my Estonia connection. And a couple of years back, we were helping Tehnopol and Tartu Biotechnology Park to bring some companies to India. So today's topic, AI in healthcare, is very interesting, very special topic. And I would like to start by asking you a question through Piret. Can anybody tell me the price of this painting? Can anybody take a guess? Yeah. Yeah. One painting, yes.
So, any guess? No idea.
So it's €500,000, and it was done by an AI. It's called, the kind of AI is called GAN, Generative Adversarial Networks. So you can feed in input of a famous painter, and then it can do, its own creation, right? So I thought I should start my talk with this nice painting, which is done by AI. Now, today's content, it's about, I will just briefly talk about these topics. And you can stop me if you have a question. So in general, I got interested in AI a year back, and I started reading. And reading is always a good way to start building your knowledge. So if any of you are interested in picking up books, I would recommend some of these books, and also a blog, the Medical Futurist. Yeah. And also want to tell you very interesting insight from a report that I was reading. It was on economic activity, the impact. So when we moved on from a hunter-gatherer society to a farming society, right, the economy would double in 909 years, right? And when we move to industrial society, the world economy will double in 6.3 years, right? And what is the next economic shift? So you can imagine that the world's GDP might double, in years to come, in few months. And that's where the economic potential of AI lies. And thank you, Tehnopol, for organizing such a seminar on this kind of a topic. So now we begin the presentation, and I believe the previous presenter gave you some insights on AI. So can anyone answer what's this pigeon doing in this picture? Piret, over to you.
Yes, so any answers from the audience? Protecting something. Detecting something.
Yeah, so that's quite close, and indeed the pigeon is reading breast cancer images, and the accuracy of this pigeon is higher than a human pathologist.
Okay, please elaborate.
So that's deep learning for you. For those of you who do not understand technology, yeah. For those of you who do not understand the kind of AI we are talking, of course, the next in all animals. So some of the researchers in US trained this pigeon to find malignant tissues in an image. And as you know, that pigeons can look at a pattern from long distance. They can spot a piece of grain. So the pigeon would get a grain if they would guess the image. So that's the salary of this pigeon, which is few grains. I don't know if you could see in this in image. There is a grain dispenser. So every time the pigeon guesses, there is a blue bar and there is a yellow bar, which is whether this image has a malignant tissue or not. And basis this training that was done, like I believe the previous speaker or the next speaker might talk about training neural networks. That's how you could train a pigeon to read pathological images, right? So it is as simple as that. Of course, I don't want to oversimplify deep learning for you, but I just wanted to give you a good example where somebody can be better than humans, not just computer programs, but even a pigeon. So now coming to some serious examples. So this is a list from 2014 onwards, which is the list of FDA approved AI algorithms. And you all know that FDA approval takes a lot of time. So which means that these companies have tested you know, the rigor that the FDA has. And the first one is Alive Core. So I imagine that the organizers will share the slides with you. So if you cannot read the text, don't worry, you can look at them later. But you can already see there is, cardiology, psychiatry, endocrinology, radiology, geriatrics, neurology, orthopedics, emergency medicine, ophthalmology, pathology, and oncology covered with various algorithms which are approved. So just zooming into one of the examples, Alive Core, it's a company which started collecting heartbeat data, and they got their first FDA clearance, and then they built this app into Apple Watch. So basically what this algorithm can do with the hardware available in the Apple Watch, it can detect arterial fibrillation, right? And it can alert, with this diagnostic data, the person wearing the Apple Watch. So coincidentally, Apple also has launched the same thing. So in a way, Apple has killed this company in some ways, because the Apple Watch comes with inbuilt ECG, and all they needed was. Second example is of dermatology. Again, a very easy AI example. There are these symptoms of skin cancer which train a neural network, like the way I talked about training the pigeon to look into the breast cancer, where the tissue is not malignant and is malignant. So skin vision is another such example where you can do screening. I give you two more examples of pathology and radiology. Both of them are Indian companies, and they are very well funded companies. So one of them is Tuple, and the other is Cure.ai. So Tuple is working on pathology data, so they can analyze blood smear, and Cure.ai is analyzing X-ray images. And you can see that their AI is already CE approved, which is European, of course. So which means that they can sell in Europe. Another interesting example I want to share from the research. So this is from a Harvard lab, from a Stanford lab, where a student has built open hardware, which is to analyze slides of infectious diseases, right? So sometimes you have to look at the pathogen, and in the field you don't have sophisticated equipment. So can AI do that for you? So this student has built this device where you can put a glass slide on top of it, and if you have for diagnosing that disease, that AI can help you on the ground to diagnose whether somebody has malaria, dengue, and those kind of diseases. So this might be interesting for those people who are looking to build but a fundamental capability of AI, and I call them as building blocks. So you can all read it, face recognition technology. And I'm sure somewhere in Estonia, in Tallinn, face recognition is used, right? So face recognition is, something which is, widely available and ubiquitous. So I share with you a paper from 2019, November 27, so which is only a week back. So you saw that example of arterial fibrillation from a live core. So some researchers are saying that they can say if a person has arterial fibrillation or not just by looking at their faces. So I think this is quite disruptive. And you can also read here that they're using deep convolutional neural network. So convolutional neural networks are a type of neural network which are very good at reading images, whether it's X-ray, this digitized slides or faces. So what I'm trying to say here, let's say in my own office, we have built an AI which does our office attendance on our faces, right? So I could build that in a month. So building something which does face recognition is not really rocket science today. You can also do it, but I think it's more interesting to find, can you go just beyond recognizing the face? Can you recognize certain emotions on the face? Can you diagnose depression? Can you diagnose arterial fibrillation in this case? So to me, face recognition is a big potential technology for healthcare in future. Another big technology that I see which is quite promising is voice. And of course, all of you know this device in this room. So Piret, or the moderator, if I may ask, can you do a survey again for me, that how many in this room own a voice activated device like Alexa or Google Home?
So raise your hand. So not too many, I would say. It's like,
okay.
Yeah, few percentage only.
Yeah, so you can see my slide, and I start on internet, let's say 20 years back, if anybody was going to internet, their identity was email and still is. But that was enabling only companies like Google. And a couple of years back, let's say 5-6 years back, a company came around and it said that, okay, the identity doesn't have to be email, it can be a phone number, and it could add couple of billion people on the internet that could participate, which were beyond email. And I think there is a third revolution in making, that if you don't have a email, if you don't have a phone number, can you still participate on the internet? So the answer is yes. So sooner or later, all of us would have these voice activated devices. I just bought one for my mother recently. It's a $40 Amazon Echo Dot, and she doesn't have an email and she doesn't have a phone. Yes, you might laugh at it, but she doesn't have a phone. So she could call me today and I could call her, right? Now, when 60 million Alexa devices have been sold in US, which is one in every US family, what is the potential for healthcare, right? So potential for healthcare is huge. One is, talking to your doctor or talking to your relatives, and can the AI analyze your voice and say something is wrong with your parents? So the answer is yes. So if you start working on anything related to voice in the medical domain, trust me, you will deploy it most likely on a device like Alexa, because it will be a very big distribution platform, right? So let me move on to the next example, which is my personal favorite. So I want to zoom on now to a disease. So I gave you 3 broad examples from cardiology, pathology, skin cancer. Then I gave you 2 examples of fundamental technologies like face recognition and voice. Now I want to give you a personal example, because I was diagnosed with diabetes type 2 last year. And I got very interested in the topic of diabetes, what's happening there. So here is some data. So this is the the year-wise publication on AI and diabetes. You can see how the number of publications are rising. So in diabetes, for example, in 2017, close to 10,000 research papers were published. Yeah. So what these papers talk about roughly? So they talk about blood glucose control strategies, blood glucose prediction, detection of adverse glycemic events, insulin bolus calculator and advisory systems, risk and patient personalization, detection of meals, exercise and falls, lifestyle and daily support in diabetes management. So I don't know if there is anybody in room who is interested in diabetes, but for me, a condition like diabetes, which I will not say is illness, is a complex situation. And to understand human body, to understand complex data, I believe AI can be an answer. So just to give you more concrete examples here. So this 13-year-old girl, Indian origin from US, took the standard Microsoft neural network ResNet 50 and built a neural network to do diabetes retinopathy screening, just with a smartphone and a contraption. So if a 13-year-old can do it, I think technology is not an issue. So there are similar examples that I have mentioned here, which are using AI in diabetes. So Livongo, Bigfoot, Gluco, Virta Health, Digital Diabetes, and Onduo. Another book that I want to highlight to you if you're interested in this topic, The Personalized Diet. And the wife of the professor, Dr. Iran Siegel, has launched a company in US. It's called Day 2. And what they do is they can predict blood sugar levels, they want to eat. So another quiz, Piret, can you ask people that which diet on this chart, diet 1 and diet 2, would give a high blood sugar response to a person?
Yeah. Any guests? High sugar. Yeah.
Diet 1,
yeah.
Diet 2.
Diet 1 is this. Mostly people thought that is diet number 1. Is it correct? Diet number 1?
Okay, so the answer is here, it's very personal. So the essence of this research is that the blood glucose response doesn't depend on what you eat in general, but it depends on your gut biome. So in this case, there is data over a number of days of both of these diets, and you can see clearly one of the diet is giving a very high sugar response. And the researchers say from this 2015 research that if you could avoid foods which are giving you high blood sugar response, as I said, it's very personal to everyone, you can actually lose weight and control your diabetes. So if you are interested in this experiment, you can look for these professors. But to give you the generic answer, there is no one diet that you can say just by looking at it that it will give you low blood sugar response. In this case, it was diet number 2 which gave low blood glucose response, but the answer is very personal. Yeah. So just to tell you a bit more about this this research, that what the professors did, they organized the stool test of the people that they recruited in the study. So they could sequence their gut biome and give them 50,000 meals over 1,000 people and record their blood glucose response and convert that into an AI that without pricking people. Normally when I want to know my blood sugar here in India, I have to prick my finger, right? So it's a bloodless method by which they are using AI to predict that if I were to eat something, what is going to be my blood sugar response once they know my gut biome. Yeah. To give you another example closer to home is from Sweden, and you could see me in these pictures. I'm standing in the Lund University Diabetes Center, and they published the most path-breaking research paper in diabetes from 2018. And the paper suggests that type 2 diabetes can be categorized into 5 types of diabetes, meaning they had a lot of patient data over 10 years, and they clustered that data that if what complication they will develop. Will they have issues with kidney, or will they have issues with eyes, for example? So what is the usefulness of this research? That if a random person today walks in Sweden, and they could look at their various parameters like BMI, HbA1c, GADA, HOMA B, HOMA IR, and say which cluster this person is falling to, so they can predict in advance their complication. So I finish my let's say the clinical examples from the real world. Some are from research, not deployed, and some I showed you which are FDA cleared. So what is the way forward for AI in healthcare? So I know that previous speaker was talking a bit about ethical guidelines, and I know that in Europe for last 1 year ethical guidelines work was taking place, and soon there will be a certification available for AI. We organized a seminar earlier this year in Gothenburg in Sweden, and one person from Karolinska mentioned that they want to change their regulation, that as a hospital, when they want to buy AI, they want to pay with data, right? Not pay with money. So I think that is a very interesting paradigm, which I think Tehnopol can also play a role, which is to find a healthcare provider and enable that data to be built into AI, and that could be a revenue stream for that healthcare provider. And I really believe that is the opportunity for Estonia, because Estonia's digital data is really probably one of the best in the world. And if you can figure out these legal and ethical and business questions, you can enable creation of world-class AI. Of course, that AI still need to be validated in other markets, and Indian patient might not be same as Estonian patient, but I think you can be a very good incubator with a data sandbox. And that also brings me to a further question, that what are the jobs for future? So it's not the jobs that everyone is going to build AI, So there are going to be 90% jobs in, cleaning data, preparing data for the AI. So only 10% of the jobs would be for building AI, in the AI paradigm, because data is the biggest challenge. So I think that's my message to folks in Estonia, that think about these. And my last point is, how can we succeed? So I believe that we don't need to build algorithms. So that is a very democratic stuff. That is standard stuff. I think innovation lies in identifying the use case, and the difficult part is getting that data organized. So I think the Estonian opportunity, and anybody who is listening to this webinar, the opportunity is in building a data sandbox. And I have built on my own already 3 AI systems in last 1 year. So starting from reading books to building systems which are live now, I can assure you that doing it is not difficult. But the difficult part is the question on the use case and the data. So I am done, Piret, here, and with my presentation I have some references for the people who are interested.
Second, we have questions from the audience.
Yes.
Yeah, so I was thinking about what you mentioned about the sandbox in Estonia, that if we basically clean up the data and give it as to be used for teaching algorithms. But how about the part that actually companies need to learn how to clean up the data themselves, or create algorithms that distinguish relevant data from the unrelevant?
Yeah, I think I didn't get your name, but if I may answer in short, I think there is a lot of opportunity to innovate, and you are very correct. Even automating that part of cleaning data and segregating data is something that people have not well understood. If big companies like Google are doing it, then that knowledge is not democratized. So I think you have a huge responsibility in Estonia, to be a digital society, to deliver, this knowledge that to the world. And I think there's a huge potential here.
Any other questions online? Do we have any questions online? No questions? Not here also. So Sachin, thank you for this presentation. And we will just, I will just say a few closing words. So this was one seminar about technical questions, but this project has also other seminars, and the topics are regulatory issues of AI in healthcare, state of the art in AI in diagnostics, and then strategy for the companies, and business models workshop, as we heard also from the first presentation, that the business model is one of the big issues. And then access to funding. This is also one of the workshops. So altogether 5 workshops, and you can follow all those workshops online through our channels. So I hope that this actually helps at least our companies to be more what's the word in English now? More brave in implementing AI in health tech. So me as a person, as a patient, I can't wait for the day actually when I go to see a doctor and I can't talk to the doctor, but I have to communicate with the AI. So thank you for participating. We will upload all the presentations as soon as we are ready, and then we will also distribute through our channels information about the next upcoming events. So thank you.